All right, then now that we know what the total fixed cost, total variable cost, and total cost curves are, let's see what they look like on a graph and talk a little bit about how they look on a graph. So the first thing that I wanted you to pay attention to is that whenever I use a lot of abbreviations, or we're going to use a lot of abbreviations in this chapter, we're going to talk about TFC being total fixed cost. TVC is total variable cost. And TC is the total cost. So you're going to see a lot of these abbreviations. Just be aware of what they are. So, and as we look at this total cost curve, you should note that output is down here on the horizontal axis and that dollars is on the vertical axis. So whenever you're drawing these graphs yourselves, make sure that you put output on the horizontal and dollars on the vertical. Now, let's start off with the total fixed cost curve. It's the easiest one to draw. Why? Because it's a straight line. So if you remember from the last video, the total fixed costs do not change. They're not going to change. They're going to remain constant. And in our example, they remain constant at $100. So whenever we're drawing this total fixed curve, it's actually just going to be parallel to the horizontal axis. It's going to be this parallel line, this orange line that is right here at $100 and is perfectly parallel as you move across. The reason why is because it remains constant regardless of the output. If you remember, these are our fixed costs. They don't change. It's like that tractor that we can park it or we can drive it 7 days a week. Either way, it's still going to cost us the exact same amount in the tractor payment. So because of that, it doesn't matter if we produce 0 units of output or 12 units of output. We're still going to have to pay this $100. So the total fixed cost curve is going to be a straight line horizontal to the axis. Now we have the total variable cost curve. You remember our total variable cost was calculated by taking the number of inputs times the price per input. And remember, these are our number of inputs. And our price per input was $5 in this example. So we have $10 or 10 hours of labor times $5 an hour gives us $50. $60 or 16 hours of work times $5 an hour will give us $80. So this curve won't remain constant, nor will it actually be a straight line going up or anything like that. But it actually is going to But it is going to rise as output rises. So think about it this way. As you produce more, you're using more inputs. So as you're using more inputs, your cost is also increasing. So your total variable cost is actually going to, and it's this red line right here, it's going to increase as our output is increasing. And the reason why is because of the additional inputs required to produce more. And as we use additional inputs, we're also have to pay more for those inputs. So it adds an additional cost to produce more. And then we get into our total cost curve. Well, remember our total cost curve is equal to the total fixed cost plus the total variable cost. So what do you think it's going to look like? Well, the total fixed cost curve remains the same. So we can just add $100 onto all of our variable costs because that's what our fixed cost is. And we come up with this total cost curve. Well, this total cost curve is going to look identical to the total variable cost curve. Only it's going to be moved further up on this graph. It's going to be higher on this graph. Well, why is that? Because that gap in between is equal to the total fixed cost. We're adding the total variable cost plus this total fixed cost. So if we were to stop and think about it at 2 units of output, we have this cost plus this cost equals this cost right here. And because of that, it's actually going to be parallel to the total variable cost curve, and it's going to rise as output rises because your total variable cost curve is rising. Your total cost curve will rise in the same way. But the gap between the total variable cost and the total cost is actually equal to the total fixed cost. And again, I want to draw your attention to how this graph is laid out. On the horizontal axis, you have output. On the vertical axis, you have dollars. So just be careful and pay attention to that as you're drawing these graphs. So kind of a quick recap, we have the total fixed cost curve. Remember, the total fixed costs don't change. So it doesn't matter at what output you're at, you're going to be maintaining a constant fixed cost. And because of that, your total fixed cost is always going to be horizontal, perfectly parallel and horizontal to the it's going to be perfectly parallel to the horizontal axis. Your total variable cost curve, it's going to rise as output rises. And the reason why is for you to produce more, you've got to use more inputs. As you use more inputs, it costs you more on the variable input standpoint. And because the total cost curve is equal to the total fixed cost curve plus the total variable cost curve, it actually shows that the total variable cost curve and the total cost curve, the TC curve and the TVC curve, are going to actually be parallel to each other. They're going to be rising at a constant rate, and the difference between those two, the space, the gap in between those two lines, is actually going to be your total fixed cost.